All right. Questions on homework? We have questions on homework? 59. Eight x squared plus 23xy, that one? Okay. 8x squared plus 23xy minus 3y squared. In the middle? Okay, yeah, let's see. You can let me know where that trouble spot is. First thing you do always when you're factoring is what? GCF. Now, do we have a GCF here? No, right? There's no numbers that go into all three terms. The x's do not appear in all three. The y's do not appear in all three, so we have no GCF. There are three terms, so we try this AC thing. So we multiply the 8 times the negative 3. That gives us negative 24. The number in the middle is 23. And so we try and come up with our two numbers, which are, negative 1 and positive 24. That works. That's the way you did it, just like that? Okay, now what we did is we take the first and last terms and we just rewrite them, right? Don't do anything else to them. And then the middle term, 23xy, we need to rewrite that using minus 1 and plus 24. So I put minus 1xy. So because I'm trying to get a 23xy, I'm going to use xy here. And then I use the 24 to put next to that plus 24xy again. Did you do 24 and then minus 1? Okay. Yes. Yeah, okay. If you did that short way, it's definitely going to be confusing because when we did this last class, I said if you have something that looks like this, you definitely want to try it with the grouping method because it'll get real confusing the other way. You were missing a y, right? Okay. So yeah, if we do it this way, then you just split it up and then you do GCF on each of the two. So what's the common factor out of the first two? X. And you're left with 8x minus y. And then you have to match that up over here, 8x minus y. So we have to be able to turn an 8x into a 24xy. So I'm missing, let's see. I need a y, but I also need a 3. So plus 3y. And I'll double check that 3y distributed to negative y will give me negative 3y squared. So that works. Since they match up, I factor out the 8x minus y, and then in the new set of parentheses, x plus 3y. Now, if you really want to know how to do it the other way, I can show you quickly. It's not too bad. Remember how I said do two sets of parentheses? And I said you put the number here, negative 1, you put the 24 here, positive 24 here. And then you put the x here and the x here, and you leave a space in front. The only additional thing is if it looks like this, that means you had x squared in the beginning, x squared at the end, xy in the middle. It has to look like that. Then you also throw in a y after your numbers. And now you place your 8 where you want it. So I would probably put the 8 here, and then the 8 underneath the 24. And that'll give you your 8x minus y, right? And then the other one will become x plus, this is 3, so 3y. Then you do this short way, yeah. Then that's all, just add the y in there. Mm-hmm. It does not matter because this is really just something times something, right? Multiplied, and multiplication is commutative. You can flip the order. Yeah. A lot of that has to do with which order you pick these numbers. If you put the 24 first in the negative one, then it can change the way things appear. Yes. 87. X squared times x minus 3 minus x minus 3. Now, the whole point of this problem is to make sure that you understand that if it already looks like this one kind of got down to this point where we had the same thing and same thing, and we just basically pulled it out, well, we pulled it out right here. Then that's basically what's happening here. We're already at that point where we have something that matches. So we pull that out in front, and we get x minus 3. And then in our new set of parentheses, what would go here? X squared from this front, right? And then minus 1, because that's really like a 1 in front there. So minus 1. Well, you're not done yet. You're not done yet, because this one right here has 2 terms, and it's a difference of squares. See it? Now, the first one, x minus 3, is not a difference of squares, but this one is. So x squared minus 1, remember, you can look at that as being something squared minus something squared. It is what? X squared, and then 1 is obviously 1 squared. So that's your A and that's your B in the formula. So we know that the x minus 3 doesn't change, but this difference of squares turns into 2 things. It's A plus B times A minus B. X plus 1 times x minus 1. And that should match the book. Yes. That makes sense? So what happens on a test if you give me this answer and not this one? Well, you can't get full credit for that, right? You get something. But I can't possibly give you full credit if it's not completely factored. Speaking of test, here's some information on the test. The test is this upcoming Tuesday. That's the 15th. If I'm not mistaken, I believe the 15th is the last day to drop the class. Anybody have the calendar with them? No? I should be able to look that up real quick. You are allowed to have when I say formula sheet, that's the one that I handed you that has the steps for factoring, right? So you can have that sheet, and then you can create your own cheat sheet as long as it doesn't have any worked out problems on it. Make sure you bring your calculator because you cannot use your phone. And then I decided to put together some problems for you to review. Now, here's the way this works. There's a lot here, okay? But let me explain how this is set up. If you're really struggling with factoring still, I mean, just even the basic parts of factoring. How do you do a difference of squares? How do you do the AC method? This first group of problems right here, all these, it's in green, I guess. You can't really tell, but this is all green. All those problems come straight from the book in what's called the chapter review. And for each problem there, they kind of tell you what you're supposed to do. Like on number 5, it'll be something like, hey, use grouping to factor. Okay, here, use difference of squares to factor. So all the first set of problems there are things that you should review if you really feel like you need more practice. Now, to truly study for the test and to see what the test is going to be like, it's more like these problems. So the ones so if you feel pretty good, all right, you feel pretty good about yourself going into this, maybe just go home and look through these. And if you have trouble with these, then maybe go back to those. The problems here are broken up into 2 groups. The first group is all factoring, all right? The second group is solving equations. And let me get to it's all page 450. Oh, you know what? Yeah. Yep. So this is all factoring. This is all solving equations. Now, we just barely started this one at the end of class last time, the solving equations. So we're going to do more of this today. That's the zero factor property. A times B equals 0. We're going to do more of that. And then what I'm going to do is at some point I'm going to let you work on some problems, about 8 to 10 problems here in class. Just give you a feel for what to expect. Any questions on that review? One other thing that you might consider doing is maybe do these problems first. You know, I don't know if you have this much time this weekend. Hopefully you do. Do these problems. And then one thing you can really do to help yourself prepare is sit down, turn off the TV, turn your phone on silent, get out some paper, get out an eraser, get out your calculator, and do these problems. Don't look at your notes. Don't look at anything. Act like you're taking a test. I think that's one of the biggest issues with students is that they never really practice a testing environment at home. They go through other notes, they get help in tutoring lab, but you never actually sit there and try and do problems on your own without any help other than your cheat sheet, you know, and your formulas, and that's it. So the first time you ever do that is when you sit in the class and then you're all freaking out. So if you practice testing environment at home, you're better suited when you come to the test, all right? That's just my advice to you. It's one of those things that I've been talking to some colleagues of mine about. When I was a student, that's what I would do. And the people I've talked to, they're like, yeah, I did that too. But I guess we are assuming that everyone kind of does that, but not everyone does. So it's one of those things you should try at least, you know. Take a couple of problems out of here, sit down, see if you can do it without any help. Okay, now we need to talk about problems like this. I believe at the end of class I gave you a problem, didn't I? Did we have time last time for a quiz? We didn't. We ran out, huh? All right, so let's just pick up kind of where we left off then. What did we end with last time? Try and remind you what we did since it's been a whole 48 hours. This is where we were, zero factor property. The zero factor property said that if two things ever multiplied to be any number, no, zero, only zero, that one of those has to be zero, right? That's what we said, and that was a major property. We said if three things multiply to be zero, then one of those has to be zero. We said that if two numbers multiply to be something other than zero, this property doesn't hold, right? It's only zero. Then I gave you an example. That was kind of trivial. And then I guess we ran out of time, right? So that's kind of where I'm going to pick up today. I'd like for us to look at this. What if we have x plus 2 times 4x minus 1 equals 0? And the instructions here are to solve. Couple of things to notice. We have an equation, right? The problems that we've been doing, the problem that I was asked to do just now, the two problems I did right at the beginning of class, did not have an equals in it, did it? So all we did was factored and we were done. But now that we're asked to solve an equation, it's going to be a combination of our factoring, but then at the end we have to do some additional steps. So let's see if we can apply the zero factor property. Do we have an equation equal to 0? Yes. Do we have things on the left side that are being multiplied together? Yes. We have two things, right? We have this, x plus 2, and we have 4x minus 1. So if you look at it in the zero factor property, it's like there's an a times Computer's acting funny. There's a b equals a 0, right? So all I have to do is figure out what would make a 0 and what would make b 0. So from this, all I have to do is create two little problems from it, because I have two factors, don't I? The a and the b. So what I'll do in class is I will draw a line down the middle, and I will write down x plus 2. I need to know what makes that 0, and then 4x minus 1, what makes that 0. So do you see how the one equation that we had with the two factors on the left side now becomes two equations, right? Now solve each of these. So let's solve the first one. To solve x plus 2 equals 0, I just need x by itself. So just do what? Subtract 2 on both sides of the equation. We get x on the left. What's 0 take away 2? Negative 2. And we are done. So if x is negative 2, that equation should be true. And now to solve this one, I need to get the x by itself. I have a 4 in front of it, and then I have a minus 1 here. So what should I do? Add 1 first, right? Don't go dividing by 4 or anything yet. Move the 1 over, so add 1 to both sides. What would be still on the left side there? 4x equals what? 1, right? 0 plus 1 is 1. And now if I want to get x by itself, and this is a 4 times x, I will now come in and divide. So I divide both sides by 4. The 4's on the left turn into a 1, so I just have x. On the right side, I have 1/4, and I'll leave it as a fraction, 1 over 4. What we're saying is that to make this original problem true, right, to make the equation true, you either need to let x be negative 2 or you let x be 1/4. In either case, we should get 0 up here. We should get this to be true. So let's just check it. What if x is negative 2? What's negative 2 plus 2 right here? 0. And what's 0 times anything? 0. So that'll be 0, won't it? Okay, what about 1/4? If I put 1/4 into here, do I get 0? 1/4 plus 2 is something, right? But it's not 0. Try 1/4 right here. What's 4 times a 4th? Or what's 1/4 of 4? 1, right? Then minus 1 is 0. So that'll kill everything off, and you'll have 0 equals 0, which is true. You see how that works? Now, if we go back and take a look at this problem from the very beginning, this was kind of the easiest case scenario we would ever have, because it's already factored, right? I already gave it to you. It was factored. Compare that to this. 2x squared minus 5x plus 2 equals 0. GCF, or no, not GCF, I'm sorry, I'm getting ahead of myself. We have an equation, don't we? Okay, we need to try and use zero factor property, which means we need a 0. Do we have a 0? Yes. Okay, so let me look at everything on the other side. Is it something times something? No, it's something plus, or actually something minus something plus something, but it's not multiplication. So how do we turn 3 terms into multiplication? We factor it, right? And that means AC method. So I'm just going to look at the left side and see if I can factor it. No GCF, right? AC method. 2 times 2, 4. Number on the bottom there, negative 5. Now I have to come up with two numbers that do that. Negative 4, negative 1, right? Now, because this is a review day and we've done so much AC method, I'm not going to go through and draw my table of all my different combinations and find it. That's what they are, okay? Now I'm going to come through. I'm going to drop my left and right-hand sides down. That'll be 2x squared. I'll have my plus 2. Now don't forget equals 0. Bring the equals 0 down. Right? Do not forget you're working with an equation now. But that middle term, the negative 5x, is now going to be what? Negative 4x minus 1x or just x, you can do it either way. So that's using my two numbers. Then what? Grouping, so split it down the middle. What factors out of the first two terms? 2x. I'm left with x minus 2, right? In order for grouping to work, I need that to match over here, so I put x minus 2 again. Now, how do I turn x into negative x? Negative 1? And let me just double check that that works. Negative 1 times x gives me negative x. Negative 1 times negative 2 gives me positive 2. So that should work. Equals 0, right? Equals 0. Now the left side becomes x minus 2 times, in parentheses, 2x plus, or minus 1, sorry, equals 0, right? At this point, it looks like the problem we just did, doesn't it? We have something times something equals 0. So now you just set each of those to 0. This is where I come in. I make two problems out of this. The first one is what? X minus 2 equals 0. The other one is 2x minus 1 equals 0. So there are my two new equations. And now I need to solve these. How do I get x by itself on the left equation? Add 2 to both sides. When you do that, you just get x is 2, don't you? On the other equation, what's the first thing I do? Add 1. And 2x equals 1, right? Next, divide by 2, right? 1 divided by 2 is 1/2. Now, you do not have to check these answers. If you did, they should work. Questions? Yes, these are the two answers. So if we take those numbers, if we were to take them and plug them into the original problem, way up here, if I plug in 2 into this, I should get 0. If I plug in 1/2, I should get 0. Do you want to check it? Well, that's up to you. I can check 2 real fast, but it'll be a mental. 2 squared is 4. 4 times 2 is 8. Okay, so I have an 8. 2, right? What's negative 5 times 2? Negative 10. So I had 8, negative 10, that's negative 2, right? Plus 2 is 0. So it is true. Now, I don't want to check 1/2, right? Well, I mean, I could. 1/2 squared is 1/4. 2 times a fourth is a half, so I have a half. Okay, minus 5 times a half, that's negative 5/2. Plus 2, but 2 is actually 4/2. So I had a half, and over here I had a 4/2. That's 5/2, and I took away 5/2. That's 0, whatever. Okay, it's 0. You don't have to check them, but they'll work. Does that make you want to throw up? I'm sorry. Sorry about that. Okay, let's look at another variation of this, because these can get a little bit tricky. How about 6x squared minus 2 equals x? I want you to try that on your own real quick. See if you can figure out. I've got to take a little break real quick. See if you can figure out what to do with that. Is it the equation? Yes. No, seriously, no one's gonna. No one would tell me anything. Y'all would tell me something, right? You're too honest. I saw a girl the other day coming down the hall, and I was going to class, and she was walking in front of me, and she had the new. You know when you get new jeans, they have like the sticker that says like the size and everything, and she had it, and I was like, okay, if I tell her, it's gonna look like I was just staring right at her. You know what? Because it was just right here. You know. So I was like, I was conflicted. Do I let her walk around the rest of the day with a sticker, or do I just tell her, hey, you've got a sticker, you know? So I didn't tell her anything. But then I changed my mind. I know, I went back to find her. I couldn't find her. Like, oh well. No, she was sitting down with some friends, and so I was. maybe, I don't know. It's all my fault. All right, so what happened here? I left and y'all all freaked out or what? Okay, you don't have zero, right? The only way you can do zero factor property is if you have zero. So you got to get everything to one side, don't you? So what you'll have to do is you'll have to, well, let's see, we have two terms on one side, one on the other. So let's try and get that x on the left side. So we subtract it, right? Subtract x here, subtract x over here. Now, on the right side, doesn't it just go away? On the left side, you cannot take x away from x squared because they're not like terms. You can't take x away from 2 because they're not like terms. So all you're going to have are 3 terms written, and notice I'm going to put them in descending order. Do you see how that x right there? I squeezed it in between the 6x squared and the negative 2 as a negative x. Do you want to sit on the end of the table there? You're okay? All right. Does that make sense? Okay, now we have a 0. So I'm going to try and get the left-hand side to be something times something. Well, it's 3 terms. Do I have a GCF? No. So 3 terms, no GCF. I go straight to AC method. 6 times negative 2, negative 12. Middle number, negative 1. That's going to give me negative 4 and 3 will work. Again, I'm not going to show that work, but do you agree those would work? Okay. Then I go and I break this thing down. I write the 6x squared. I write the negative 2. I put my equal 0. In the middle, I will have what? Minus 4x plus 3x. Are you all comfortable with that step? I mean, I guess that's kind of a rhetorical question, right? I'm asking you to ask yourself, but not really answer me, right? In my last class, I did a review similar to this, and I'm going through this, and I'm like, to me, I feel like I've done so many of these problems with you that at least the idea should be clear. And if you've been doing your homework, you should have done enough of them yourself too to feel like this is just kind of becoming monotonous. But when I walked around in my other class, there were still students that did not know how to go from here to here. So I'm just a little concerned. A 187? Well, I know 187 is, but I've heard 180. Okay. Whatever. It's okay. 187, you're still kind of pointed in the opposite direction. Not quite opposite, a little bit opposite. A couple degrees off, but I'm with you. Well, you know what? I agree, but I also challenge you to challenge your own thinking there. If you think that every one of these problems is completely different, then it is going to be very hard. They all have common structure to them. I mean, every one of these has something in common. All the AC methods have the same format. You multiply the front and the back. Yes, it is different. Those numbers you come up with might be different problem to problem. But once you generate the numbers, What you do with them, and from then on out, is pretty much the same. So try and, instead of focusing on how different everything is, try and focus on the similarities if you can. It might make it less of a headache for you. Yeah. Yeah. Mhm. Yeah. And it may not, right? And it may not. Yeah. And that's the challenge of factoring, honestly, because every problem in that sense, that's what we're looking for. That we're looking that you can get to a point where, given a problem, you're comfortable with the fact that it could be a variety of different things happening. Okay, what is my GCF off the first two here? 2x. What's left inside? 3x minus 2. Okay, I need to match that up exactly over here, 3x minus 2. And hey, I have 3x minus 2, don't I? But you always have to put something out in front of this. Remember that? Plus 1. Oh, my equals 0. Don't forget your equals 0 here. All right. Pull the 3x minus 2 out. What will be left? 2x plus 1 equals 0. Okay, can we now use the zero factor property? Yes? We have two things that multiply to be 0. Set them both equal to 0. So I'll split this up. 3x minus 2 equals 0. 2x plus 1 equals 0. On the first equation, oh, what? Oh, okay. I thought you said something else. Plus 2 plus 2. 0 plus 2, right, is 2. So adding 2 to both sides. Then finally, divide by 3. And just leave it as 2/3. The other one, minus 1 both sides. That gives you 2x is negative 1. Then divide by 2, negative 1/2. Look, on all the problems on the test that have an equation in it, you're going to have answers that you box like this. On the problems that don't have equations, it's just going to be factor, and that's it. You'll leave your, whatever times whatever, leave it in parentheses, and you're done. All right. How about this one? Five x cubed equals 20x. Do we have an equation? See an equal sign there? Yes? Okay, we can use the zero factor property if we can get it to be a 0. So one of those needs to be moved to the other side. Move the 20x. Now the reason we'll do that is because the 5x cubed is a higher power, right? And it's already positive. So I'm going to move the 20x over. When it goes over to the other side, it changes signs and becomes negative. Now technically what I'm doing is subtracting 20x on both sides. So I get 5x cubed minus 20x, because I cannot subtract those, right? I cannot use zero factor property yet because I do not have something times something. I have something minus something. So my only hope is to try and factor. First step of factoring. GCF. 5x. What will be left? X squared minus 4 equals 0. All right, do I now have something times something? Yes, but this is a difference of squares, isn't it? X squared minus 4 is a difference of squares. So those are the types of things you want to start seeing, right? Oh, x squared minus 4, difference of squares, yay. What does it turn into then? X plus 2, x minus 2 equals 0. Now do I have something times something equals 0? I actually have something times something times something equals 0, but that's okay. If we have 3 things, then instead of creating 2 equations, we're now going to create 3. So I have one, well, I'll make a little more room there. Here are my 3 equations. First thing is I want to know when 5x is 0. The next one is x plus 2 is 0. And the last one is x minus 2 is 0. You see where those come from? How about that first equation? Divide both sides by 5. What is 0 divided by 5? 0. So your answer is 0 here. The next equation, subtract 2 on both sides. You get x is negative 2. The next equation, add 2 to both sides. You get x is positive 2. There are 3 answers: 0, negative 2, and positive 2. One last problem, and then I'm going to give you some stuff to work on yourself. I want you to carefully investigate the following 2 problems. I'm going to put 2 problems up on the board for you. X plus 2 times x minus 3 equals 0. I want you to compare that, so versus this problem. X plus 2 times x minus 3 equals 14. So we're comparing 2 problems here. That's supposed to be a versus in the middle, like versus. They're very similar, aren't they? The left sides of those equations, they are both equations, are exactly the same. It's the right side that's not the same, right? In the first equation, it's 0. In the second one, it's 14. So on the first equation, can't we just use the 0 factor property right now? I have 2 things that multiply to be 0, so I can set each one equal to 0 and be pretty much done. I set x plus 2 to 0. I set x minus 3 to 0. On first equation, x is negative 2 because I'll subtract 2 from both sides. Next one, x is positive 3. And I'm done, right? So when it's 0, this is somewhat trivial, right? Just work it out. Here, though, we cannot. So your instinct might be, all right, well, let's get 0 over here. So how do I get 0 over here on the right? Subtract 14 on both sides, right? Now, do not write this down. I just want you to see what happens. If I subtract 14, because the left side was stuff being multiplied, that 14 that I'm subtracting has to sit out here by itself. It cannot go in here because this multiplication comes before addition or subtraction. So you cannot combine the negative 14 inside those. So once I move the 14 over to the left side, do I still have something times something equals 0? I have something times something minus something. And the only way 0 factor property works is if I have something times something, or maybe something times something times something. It all has to be multiplication. That negative 14 is screwing everything up. Do you see that? So here's what we're going to have to do. And it's not going to seem very natural, but it'll work. Since that 14 is causing me problems, I'm going to take the left side of this, and I'm going to expand it or FOIL it out. what I mean is x times x is x squared. X times negative 3 is negative 3x. 2 times x is 2x. And 2 times negative 3 is negative 6. Now the right side of that equation is still 14. And I know you might be saying to yourself, well, wait a minute, why in the world would we do that when we really like to have things factored? Why would I undo this? It was factored. Well, the reason you have to do it is because of the 14. The 14 is preventing you from doing anything with this. All right? Now, let's look at this left side. X squared, what's negative 3x plus 2x? Just negative x. And then I have minus 6 equals 14 still, right? Can you get this to be equal to 0 now? Yes? Bring the 14 over. Subtract it now. When you subtract it, won't it subtract from the 6? Negative 6. Minus 14 minus 14. What do you get? X squared minus x minus 20 equals 0. And now you have 0. You have 3 terms, no GCF. You can do AC method on this. Yes. These two right here put together to become this. Because negative 3 plus 2 is negative 1, and I just didn't write the negative 1. Yeah, there's really a 1 in there. Okay, so let me do an AC method on that right here. What are my numbers? Negative 20 and negative 1, you come up with something like 5 and 4, but 1, not, negative 5 and 4, right? Negative 5 and 4. These multiply to be negative 20, add up to be negative 1. I'm going to skip this step. I'm just going to go straight to it. So I'm skipping the grouping, okay? Because like I said, we've done enough of it. If you do the grouping, you should get x minus 5x plus 4. Right? And now you can use the 0 factor property and set them both equal to 0. See what we started with? X plus 2, x minus 3 is 14. And we've transformed that whole thing into this x minus 5, x plus 4 equals 0. I promise you a problem like this on the test. I promise. Just one. Because here's the important thing. You must be able to recognize when it's just simple set each factor to 0, like this one, versus when you cannot do that. Because that's the big no-no with students, is that they'll take an equation, they'll factor one side out, and then it'll be equal to like 14 or something that's not 0. And then they go and they try and set each of those things equal to whatever's over here, like 14. It won't work that way. So what are the answers here? I didn't work it the rest of the way. So you take those, set them equal 0. X is 5 and x is negative 4. What do y'all think? No? Just be thinking, you know, when you're doing these problems, I think the first thing you should ask yourself when on this test, the first thing you should, when you're sitting at the problem, you should ask yourself, when's the drop date? No, I'm just kidding. You should be sitting there and going, is this an equation or not, right? Because if it's not an equation, you're going to factor like we've been factoring. If it's an equation, then you know you're going to need the 0 factor property at some point in time. So that's the first thing. So once you've determined that, if it's no equation, then you go through your steps for factoring. GCF, how many terms? If there's 4 terms, grouping. 3 terms, AC method. 2 terms, look for difference of squares, sum of squares, difference of cubes, sum of cubes, right? With this, if it's an equation, is it equal to 0? No? Move things over. Look at the left side. Is it factored out? No? Factor it. How do you factor? GCF. 4 terms, 3 terms, 2 terms. So, yeah. Okay, here's what you should do now. I want you to do this in class. Try. You can work together. You can use your notes. These are some problems that I think are all fair game problems for the test. Right? So this is a good sample of problems. This is coming off page 453. Problems 6, 8, 10, 11, 12, 14, 16. You're doing these in class. 17, 19, and 20. See how many of those you can get done in the next, 20 minutes? I know that's not a lot of time, but how many problems are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 problems. I think your test is going to be somewhere in the neighborhood of this length. Somewhere in the neighborhood of 10 problems or so. Okay, does anybody need a book? No one at that table has one? No? You have? Everyone else has access to a book? Yes? No? No here? Yeah. Why don't you go sit over there, Katie, since there's like 3 or 4 books at that table. Is that all right? Okay, thank you. Do you want to move over here? I will. I'm going to take attendance when you are done with this. All right. I will put the answers to these problems up on the board. Your goal is to get to that answer. Pardon me? Numbers 19. These are equations. Yeah. Yeah, the only ones that are equations are 19 and 20. Yep. Yeah, all the problems are factoring problems except 19 and 20. 19 and 20 are equations.